Hello students, I hope you enjoyed lesson 1. Today we will continue. We look at lesson 2 of the Pythagoras theorem. Remember, I told you that the Pythagoras theorem, it can also be called the Pythagorean theorem. In the previous lesson, we looked at a right triangle and we said that Pythagoras theorem only works for right triangles. A right triangle has got the biggest angle as 90 degrees. So, for the Pythagoras theorem, we said that the longest side is side AB, and that is what we call the hypotenuse. So AB squared equals BC squared plus AC squared. For that case, remember, according to this right triangle, AB is the same as C and BC is the same as A and AC is the same as B. So we can also say A squared plus B squared equals C squared, and that is the Pythagoras theorem. In lesson 1, we looked at examples 1 and 2. Today, we will look at examples 3 and 4. Now, in example number 3, it states ABC is a triangle with AB equals 3 centimeters, where angle ABC equals 90 degrees. If point Q is on BC and it makes BQ equals QC and AQ equals 5 centimeters long, we see a triangle ABC. AB is 3 centimeters. Angle ABC is 90 degrees. Point Q is on BC and BQ equals QC. AQ equals 5 centimeters. Now we want to find the length BQ. Now, since we see that this triangle is a right triangle, we will use the Pythagoras theorem. Now, we will extract triangle ABQ. We will get triangle A, B, and Q. Remember, AB is 3 centimeters and AQ is 5 centimeters. So we will use the Pythagoras theorem in order to find the missing side BQ. For that case, the first step is to identify what is the hypotenuse. Remember, hypotenuse is the longest side of a right triangle. So for that case, you can see that the longest side is AQ. So we say AB squared plus BQ squared equals AQ squared. Now, remember, AB is 3. So that's why we say 3 squared. Plus BQ, remember BQ, we don't know it. It's what we are looking for. Equals AQ, which is 5 centimeters. That is 5 squared. So, we will make BQ the subject of the formula. This means that we will take 3 squared to go this side, such that we have 5 squared minus 3 squared, and that is 25 minus 9, which gives us 16. So we need to get the square root of 16. Remember, we need to use the positive square root because we need the length, and the length cannot be a negative. So we must get positive 4. Therefore, BQ equals 4 centimeters long. Next, we will now find the length AC. Find the length AC. Remember, our triangle is right. That is A, B, and C. For that case, remember, BQ is 4 centimeters, as we have seen in the previous example. And we see that BQ is equal to BQ is equal to QC. So it implies that if BQ is 4 centimeters, also QC is 4 centimeters. Now for this case, let us find the length of AC. Now let us draw the right triangle ABC, and we will not include Q. For this case, remember AB is 3 centimeters, but BC will be 4 plus 4, which is 8 centimeters. And now we need to know what is AC. As I told you, since this is a right triangle, because you can see that angle B is 90 degrees, so we can use the Pythagoras theorem. The longest side is AC, so AC is the hypotenuse. So we say AC squared equals AB squared plus BC squared. AB is 3, so that is 3 squared, and BC is 8, so that is 8 squared. So that is 9 plus 64, that gives us 73. So let us find the square root of 73. Now for this case, let us use the square root table. And you can see that this is 73 and the square root is 8.544. So we can round this to 8.54. So we say that the length of AC is approximately equal to 8.54 centimeters. Okay, I hope this is really clearly understood. So we can move on to another example. Example number 4. ABC is a triangle with angle ACB as 90 degrees. If point P is on BC and it makes BP equal to 21 centimeters, PC equals 15 centimeters, and AP equals 25 centimeters. Let us show this in a diagram. We have triangle ABC and angle ACB is 90 degrees. So this means that this is a right triangle, because we can see that the biggest angle is 90 degrees. So that is a right triangle. Then point P is on BC and BP equals 21 centimeters. BC equals 15 centimeters. And AP is 25 centimeters. Now we need to find what is AC. What is the length of AC? Now, let us draw a triangle ACP. And remember, it is a right triangle. So since this is a right triangle, as you can see that angle C is 90 degrees. So we can use the Pythagoras theorem. Remember, BC is 15 centimeters, AP is 25 centimeters, and we need to know AC. So we need to identify the hypotenuse. The hypotenuse is always opposite the largest angle. So BA is the hypotenuse. So we can say AC squared plus BC squared equals AB squared. So we don't know AC, but BC is 15, so that is 15 squared, and AP is 25, so that is 25 squared. So we can make AC the subject of the formula, so we have to take 15 squared this end. So we shall get it as AC equals 25 squared minus 15 squared. So that is 625 minus 222. So that we get 400. So we take the positive square root of 400 and we get AC as 20 centimeters. So you can note that AC is 20 centimeters. Let us now find the length of AB. Remember, BP is 21 centimeters, BC is 15 centimeters. AC, we have just got 20 centimeters. And AP is 25 centimeters. Now we need to know what is the length of AB. So we can draw the triangle ABC, and you can see that it is the right triangle because angle C is 90 degrees. So BC will be 21 plus 15, which is 36, and AC is 20 centimeters. We need to know what is the length of AB. Since this is a right triangle, we can use the Pythagoras theorem. And the hypotenuse is the line, or it is the side that is opposite the right angle. So that is AB. So AB squared equals BC squared plus AC squared. So that is BC is 36, so we say 36 squared, and AC is 20 centimeters, so we say 20 squared. So we get 1296 plus 400, and we get 1696. So we need to find the positive square root of 1696 such that we get the length AB. If we use the calculator, you can see that the square root of 1696 is 41.18, and we can round it to 41.2 centimeters. I hope that really you have understood how to find the missing side of a right triangle using the Pythagoras theorem. To get more examples and practice questions about this lesson, please get this textbook on page 62 to 71. In the next lesson, we will see how to apply Pythagoras' theorem in real life, and that will be on page 72. Thanks for watching. Goodbye.